Hi class, we're going to take a look at graphs at h comma k. And let me first explain the idea of h comma k on a basic graph. So if you take a look at the following graph, such as y is equal to x to the second, x to the second is going to have a reference point at technically the origin. So the vast majority of our graphs actually have a reference point at the origin. And then if you were to modify the reference point by modifying the function, so for example, if instead you have x plus 1 technically squared, and then I'm going to add 3. Oops. 3. The new reference point has been moved at that position of negative 1 comma 3. So we're talking about this new reference point. Now, in order to find the new reference point, you're looking at what makes the parent graph 0, and then technically that 1, it's going to be your vertical translation. So in a quick shortcut, we would have just started this one at negative 1, 3, and then not to scale, but we would have drawn a parabola opening upward. Now, let me actually show you what I expect you to do on the h comma k. And I'm not sure what you did in your previous math class, but all I need is a basic sketch. And you're only responsible for h comma k on the basic graphs. So anything that you've ever talked about, logs, all of those you're responsible for. And let me explain all I need for these graphs. So all I need is an actual coordinate point, whether that is the actual intercept or y-intercept, that's perfectly fine. Now, let me look at this one. So technically, your this is a linear one, and your y-intercept, it's a 0, 1, and it has a slope of negative 3/2. So technically 0, 1 is there. From there, you're going to go 3 units down, 1, 2, and 3, and then 1 and 2 to the right. So your actual graph, it's going to be this line going in this direction. So that's your graph for technically a linear one. It's just that the y-intercept of 1, and it has a slope of 3, 2. Now let's take a look at one that matches similarly to the one that we just did on the decimals. So let me actually find you the reference point. And your reference point is what makes that 0. So in this case, negative 3 comma, that's your y value. So negative 3, 1, 2, 3. That's going to give you that point there. Because you have a negative, your parabola is not going to open upward. It's going to open downward. And I really just need the reference point. We're looking at a basic sketch for all of the graphs that you're doing. Let's take a look at graph C. The reference point is negative 4 comma negative 2. So 1, 2, 3, 4, 1, 2. It's going to be there. This is a cubic function. So from the reference point, it's actually going to go in this direction and then in that direction. That's going to be our cubic. The next one, it's going to be a technically square root. So we're looking at negative 2 comma 1 for the reference point. So negative 2 comma 1. And then because your actual graph is not opening upward due to the negative, your graph is going to open downward. So let me take a look at E. And the reference point of E, it's technically 4 comma 0. So 1, 2, 3, 4. And then this one is a cube root. So your cube root, I don't think we've drawn one of these. It's going to be this specific one. Except that at the new position, So because of the negative, instead of opening upward, it's going to open downward, and then it's going to be in this direction. So it's basically this graph, but the portion that happens to be on the positive, it's going to be on the negative. What used to be negative will be positive. So that's the actual sketch that we're looking at. Now, the next one is a little bit tricky because we typically look at these graphs and provide basically the asymptotes, which is technically they're intercepting at the reference point. So this one's going to have a -4 comma -3. So 1, 2, 3, 4, 1, 2, and 3, it's technically there. And then you're going to draw your dotted lines. And then this is a basic hyperbola. So technically you're going to have one of the u's in this position and another one in that position. So that is our actual graph of 2 over x plus 4 minus 3. Now let's take a look at the next one, which is -3 comma -4. So 1, 2, 3, 1, 2, 3, 4. And it's a basic parabola. So let me just switch. So your parabola, it's gonna go in that direction. Next one, absolute value function. So -1 comma 0. This is supposed to be a -1. So -1 comma 0. And then you're gonna have a v going in that direction. Let's go to the next one, reference point -1 comma 0, which is technically the one that we just used. It's a square root function, so your square root, it's gonna go in that direction. Next one, 9 comma 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9 comma 0, and you're gonna have dotted lines since technically it represents a hyperbola. And then one of the hyperbolas is going to be here, and the other one is going to be at the bottom. Now let's talk about the actual log. So for this specific log, you cannot have 0 on it. So you're going to have that x is not equal to -1. So at -1, you're going to have the used to be 0. And then technically -4. So 1, 2, 3, 4. Okay, so let me give you the reference point for this one. So the reference point, it's going to be whichever value makes that technically negative, whichever value makes that 1. So only 0 will do it. So 0 comma technically -4. So that's going to give us this value here. Since it has the same idea as the regular log, your actual function, it's going to go in this direction. And once again, I just need a basic sketch of this particular one.